Hi there, I'm Mansoor Ahmad. I teach radiology at the University of Minnesota School of Dentistry. In this video, we are going to learn about iCATVision software. This is the default software that comes with iCAT CBCT unit. If you get a CD from the radiology clinic containing CBCT data, the CD will also include iCATVision. This is a free software. Therefore, you may install it on any Windows computer. Today we are going to use iCATVision to review a CBCT scan. We use this scan to teach a Periodontics Honors course. It does not matter whether you are taking the Periodontics Honors course or the Summer CBCT Interpretation course. This video is for you. In this video, I am going to teach you about the software and image manipulation. If you are enrolled in the Periodontics Honors course, you will receive a zipped folder. If you are a D3 student and want to have the software and the DICOM file, just send me an email. I'll send you a link to download the files. In this zipped folder, there are two files. One is the iCATVision software, and the other is the Perio Honors CBCT DICOM folder. Inside the Perio Honors folder, there are a few hundred DICOM files. The patient data has been anonymized. So you may install and use this data on your own laptop even if it is not managed by the university. Please drag these two files to your desktop. Remember, this app will only work on a Windows computer. This is my desktop. I have iCATVision and Perio Honors DICOM folder. Let's explore the Perio Honors folder. The first folder is the date of the scan. A click once again will take us to a different folder. Inside this folder are all the DICOM files. So you can see that there are about 307 individual DICOM files. These files have an extension of .dcm or DICOM file. Let's run iCATVision. The first screen that appears is an error stating that there is a newer version of iCATVision available. Not true. We have provided you with the latest version of the software, so click No. So the iCATVision has opened. There are several windows. None of these are populated. This window will have the list of the scans. There is no scan, so we have to do something manually. First, we'll select Tools, and under the drop-down menu, we'll select Setup. On the screen, let's identify where the root folder is. The root folder, it should be in the C drive in a folder named Image Root or Local Root. If it is Local Root on your computer, you can leave it as it is or you can select Image Root. The way we'll select is by Browse on the C drive and you find either Local Root or Image Root. I'm selecting Image Root. Software may ask you to close the app and start back again, and let's do that. Let's close this and we'll start back again. Coming back to the desktop screen, we are going to put our DICOM folder in the image root or the local root. So this is my DICOM folder and this is my PC. So let's click on this PC. Funny that I have so many drives. You may have only one or two. Look for the C drive. Inside C drive, I have an image root. This folder or the local root folder was created by iCATVision. So I'll open image root and I'll drag the DICOM folder inside this image root. In the future, whenever you receive a CD from the radiology clinic, you will look for the DICOM folder in the CD. Then you will drag the DICOM folder to this image root. It is always faster to view a DICOM folder from a hard disk than a CD. So let's close this and open iCATVision again. Click No. There's no new software. Here, now we have our patient populated. As I had mentioned earlier that this scan has been anonymized. Otherwise, you will see the first name and the last name of the patient. You can change the order of the names by clicking here. Other demographics like patient's ID, date of birth, gender, and other things are here. All other windows are still not populated. If we click on the name of the patient, this window populates now. If we have several scans from the same patient, you will see multiple entries. Currently, we have only one scan. So this is a CT, this is the date of scan, this is the resolution, 0.2 millimeter, and this is the field of view. So we know that this is a scan that contains only the maxilla or the mandible. And we'll see that this is only a mandibular scan. A scan that has both the jaws will have a bigger field of view. Clicking on this CT, we have started to load the scan. So now all the screens are populated. This screen is the study information. This is a reconstructed panoramic view. Not the best, we'll fix it. On the lower panel, there are three views: a sagittal, a coronal, and axial. Clicking on these windows will take us to another screen. Before we click on any of these screens, let's do the setup. So it's a contour line setup. As you can see, the panoramic is not ideal. The left ramus is not shown. We'll fix it. There will be occasions when you will have the head rotated or the chin is up or down. We can fix that also. Let's start with selecting the contour lines. There are two choices. One is maxilla and one is the mandible. Our scan is only for the mandible, so we'll go with mandible only. So we'll click OK. The contour line for the mandible is a green line. If you had selected the maxilla, you would see the maxillary line is a red line. In this green line, you see multiple blue dots. And also you can see that the green line is not aligned with the ramus. Let us correct that by selecting these blue dots. We'll be moving each blue dot at the midline of the mandible or in the areas of pulp chambers. So as soon as you start moving the blue dots, the reconstructed panoramic radiograph starts to appear better. See, it has become much better now. I'm going to move other blue dots. I'll move this green line to the level of CEJ, and you can see that as I bring my cursor over the green line, the cursor changes. So let me move this up to the level of the CEJ. I'll put this blue dot on the pulp chamber of the canine, this blue dot between the two central incisors, this blue dot on the pulp chamber of the canine, and align this here. Maybe I'll bring this blue dot a little bit closer to the posterior border of the ramus, and this one also close to the posterior border of the ramus. So maybe we have spent a minute or two. We do not want to repeat this again, so I think we should save this. So to save this, let's right click, and it says save this workup. So you can see that this software does not have any toolbars. All the tools are on your mouse on your right click. So I'll go with save this workup. So this brings us to a new screen and we'll create a new workup. I'll call this as Perio Honors. You can give any name. Click OK. So we are done for today. If we close this app and if we come back later, we'll see that our workup has saved. So let's close this. And now it's tomorrow. We're back to the same program. Here is the Perio Honors. We click on this. This is the date of the scan. We click here, and now it comes with an option to select a workup. So I'll select Perio Honors. See, this time our left ramus is properly in the focal trough because we had set it up this way. Let's review a little bit more. As I had mentioned, iCATVision does not have any toolbars. All the tools are on your right click. Also, the cursor does different actions on different parts of the screen. Here, Towards the bottom of the screen, the cursor is a W indicating windowing. When the cursor shows windowing, you can change the density and contrast. Hold your left mouse button and you will be able to change the density or contrast. Up and down or right to left, it does density and contrast. There are no numerical values, so you go with the density and contrast that you like. I had earlier mentioned that a scan may have been obtained with the head rotated or the chin down. We can fix that also. On this sagittal view, we can see the occlusal plane is parallel to the border of the computer screen. Maybe one day you get a scan with the chin down. So how do we fix that? Bring the cursor to the bottom right corner of this window. You see the cursor has changed the shape to a half circle. Press the left mouse button, a red grid appears. Now holding the mouse, you can move the chin up or down. Let's move the chin down and see the effects. And you will see the changes on the top screen where we have the panoramic view. And you can see that the chin is down. The chin is also down here. If the head is tilted, something like this, we can also fix that. Or maybe the head is rotated. So I think I have messed it up. So how do I go back to my ideal position? So right click. So the messed up position, I saved it under a new workup name, and then I'll select the Perio Honors workup. So I'm back to the ideal position. So by now we have learned how to open a scan, how to adjust the contour line, how to save workup, and how to adjust the rotation of the head. If you click on any of these screens, it will take you to another window. I'll be spending some time with these three windows. Let me start with this window, an option that I rarely use. Double click here. It will take you to a new window for orthodontic analysis. There are better software such as Dolphin that do orthodontic image analysis. I'm not an orthodontist, so I do not use this window that much. So by clicking here, we come to a cephalometric screen. So this is a lateral cephalometric with the outline of the tissues, lateral view of the right side of the mandible, lateral view of the left side of the mandible, a PA view, and through the midline. So I don't use this window that much and I want to go back. So how do I go back to the previous screen? There are two options. I can bring my cursor to the upper left corner. And you can see that it has changed into a large X. If I click, I'll go back to the previous screen. Or I can select from the screen and go to preview screen. Let's use the large X and go back to the previous screen. So click here and you are back to the previous screen. This is the screen that I use all the time. Double click on this and it will take you to a new screen called Multiplanar reconstruction. Get used to this screen. The main purpose of a CBCT scan is to view the craniofacial area in multiplanar reconstruction or multiple plane reconstruction. So this is multiplanar reconstruction or MPR. There are four windows. One is blank. We'll use this later. This window is the axial section. This is the sagittal section. And this is the coronal section. Each window has a crosshair of different colors: green, blue, or red. And each window has a different border: red, green, or blue. The green line refers to the green window, the content on the green window. You can change the locations of the crosshair. So if I hold the green vertical crosshair and you can see that the image on the top right window is changing. The sagittal window is changing. If I take the blue, you can see that the bottom window is changing. Same with my red crosshair. You can see the axial view is changing. At this time, let's review what our cursor does. As I had mentioned earlier, on the bottom of the screen, it's a W, or the density and contrast. This is the windowing. By holding the left mouse button, we can change the density and contrast. We learned that earlier. If we move the cursor towards the upper right, we see a magnifying glass or a zoom tool. You can make the image larger or smaller. I'll fill it up to use the available real estate. If you bring the cursor towards upper left, you see a positioning tool, and it changes the position of the image on the screen. As I had mentioned, there are a lot of tools under left mouse button. So let's review this. I'll click here. We'll skip irregular for now. Let's go with the line. Because our jaw is a curved bony structure, a true sagittal image is not very useful. So if we select the line tool, I can make a custom slice. So line, select, and I'm going to draw a line here. So you see that I am using the fourth window now. This is a custom slice through the mandible. Not a true sagittal, but a modified sagittal view. You can make this custom slice in any orientation. Here, or here, or through the long axis of a tooth. Whatever way you want to do, these are custom slices. So let's unselect the line tool. The next option is HU statistics. This stands for Hounsfield statistics. This gives a numerical value of the density of any structure. A CBCT scan is not very reliable for density measurement, so I do not recommend using this, but you can get an overall idea of the density. A CT scan is much more reliable. So by selecting HU statistics, we have a new shape of the cursor. I'll make a small square here. On the top here, I see the value. The cortical bone is showing a value of about 800. If I come to the marrow spaces, you see that it drops down to about 10. So you can see the density difference between the trabecular bone versus the cortical bone. Let's unselect Hounsfield statistics and go with distance. So this is easy. You can measure any structure on the image, and this is reliable. You will be using it all the time. So here, this is the vertical dimension. I got it about 26 millimeter. This is the labial lingual width, and I got about 8 millimeters. If you make a mistake, right click here and remove a measurement or remove all the measurement. I can remove all. Now let's select the next option is Explore. I hardly use this tool. This allows you to see one particular structure in any orientation. Let's say that we want to see the odontoid process. So you bring it here. If you bring the cursor near the red circle, you see a ladder like a hamster's steps. And so on the bottom, the odontoid process you are seeing continuously. So basically this tool allows you to look at one structure from many different angles. So let's stop it here. Explore speed is self-explanatory. It's the speed of the rotation of the Explore ring. Let's go and select filter. Leave it at sharp and mild or normal. Let me show you an example of very sharp. The image becomes very pixely. So very sharp. This is how the image looks like. Not very diagnostic, so I'll go and leave it back to normal or sharp and mild. Next option is reset windows and level. Before we select that, let me change the density and contrast of this particular screen. So with the W tool or windowing tool, let me change the density and contrast, and obviously this is non-diagnostic image now. So if I go and select reset window level, it comes back to the original condition. Reset all windows means the density and contrast of all three windows will correct itself. Next is save as JPEG. So again, self-explanatory. So if you select on save as JPEG, it saves an image. To find that image, select open output folder. And these are the images that I had saved. I had just clicked 2 or 3 times. So these are the images that I have saved. Finally, reset volume rotation. If you have rotated the volume, this option will bring it back. So let's do that. If you remember, towards the bottom right corner, we have a half circle option that rotates the head. Maybe here. It's rotated. So everything is messed up. So if I say reset volume rotation, it will bring us back. Now we'll go back to the preview screen. Again, we can go back in 2 different ways, bringing the cursor to the top when it becomes a large X, or by selecting screen and then preview screen. Both of them will do the same task. So let's select preview screen. Let's review this axial section very quickly. This screen is to view the temporomandibular joints. On this scan, we do not have the condyles. If we had, we could see the joints using this screen. So let's go over this very quickly without having the condyles. So double click here. It brings you to this particular screen. If I had condyles, I would move these blue lines to the area of the condyles. On this screen, I'll move the lines to line up with the condyles. Remember that we do not have condyles, so I'm just putting these on the ramus. By doing this, you will end up with the right condyle on these 9 images and the left condyle on these 9 images. These would be sagittal sections, and this would be the coronal section of the right condyle and coronal section of the left condyle. So let's go back again to the preview screen, and you have 2 options, either the X or the preview screen. I'll use the X. So here we are back to the preview screen. We have already reviewed the function of the sagittal screen, the coronal screen, and the axial screen. So now we'll be using the panoramic view, and we'll double click this. This view is also important for your daily practice. This screen will allow us to study each tooth. So let's orient ourselves. The top left is an axial view. The bottom left is a 3D reconstruction. This is not the best. There are other software much more expensive than this free software that will do a better job at 3D reconstruction. So probably you will not use this view that much. On the top, we have a reconstructed panoramic radiograph. On the bottom, we have a panel of images, cross-sections through the teeth. iCATVision calls this window as implant screen. There are 3 ladders on the screen, a horizontal, one at an angle, and a vertical. We had seen similar ladders on the multiplanar reconstruction window. Let's go over this now. Each ladder has 3 marks, an M, an open blue circle, and a closed blue circle. Let's start with this M. It has 2 options, C as an MIP or C as a radiograph. Currently the selection is show as radiograph. MIP stands for maximum intensity projection. With MIP, we'll see the dense structures only. So let's select that. So the bone is flat, we see the roots, we see the endodontic obturation, and we see the implants. There are some clinical uses of MIP view. Let's go back to the radiograph. So we'll select Show as Radiograph. So this blue dot indicates size of the focal trough. Currently it is set at 15 millimeter. So these three green lines represents the focal trough. If we measure, so to measure, we take the distance tool, we measure from this corner, and I'm doing a rough measurement very quickly. And we got about 15.31. So that's the focal trough. The 15 millimeter width is good enough for a mandibular arch. If you have a scan with both the jaws, I prefer to widen it to about 25 millimeter. So to do that, select here, move your mouse towards the upper part of the screen, and you see that I'm now at a thickness of 26 millimeter. This is how the image looks like, and that's the focal trough. If you move the mouse to the other direction, you start to make the focal trough narrower, and the lowest that we can go is 0.2 millimeter. So that's a bone thickness of only 0.2 millimeter. We could go up to 0.2 millimeter because the scan had a resolution of 0.2 millimeter. So let's go back to our ideal, which is 15 millimeter. Leave it here. That's how it was. So this is the focal trough. By clicking on this blue, center blue open circle, we can change the location of the focal trough. And you can see on the axial view where the focal trough is changing. So if I move it here, I'm outside of the focal trough now. And if I bring it here, I'm too far lingual at this time. So let me go back and try to fit it along with the midline of the mandible. Let's go to the vertical ladder. Selecting the MIP changes the image on the axial view. I hardly use it. So let's go back to Show as Radiograph. If you select the center blue dot, you will be able to change the image on the bottom panel, moving up or down. You can do the same task by selecting the positioning tool on any of these images. Now let's come to the bottom horizontal ladder. Again, it has an M, open blue circle, and a closed blue circle. There are three vertical blue lines. These blue lines represent the images on the bottom screen. This blue line represents the image on this window. The center blue line represents the image in this window surrounded by this blue border. And this blue line represents the image here. So this blue line represents the lateral incisor, so that's the lateral incisor. This blue line is through the midline of the central incisor and it's here. And this blue line is between the lateral incisor and the canine on the left side. In between, we have all other teeth. If we click on the closed blue dot, then we see that the thickness is 2 millimeter and spacing is 2 millimeter. This means each window has a tissue volume of 2 millimeter, and between one and the other window there is a space of also 2 millimeter. Let's make this smaller. And we can go down to 0.2 millimeter. So the 0.2 millimeter is because that's the lowest resolution of the scan. So what I have done now is I'm taking the central blue circle. So I'm going to put this on this canine. So these all images are of the same canine. So this image is the most distal of the canine and this is the most mesial of the canine. Holding this central circle, I can change the location. So now I'm going to the premolar on the other side. So that's the premolar with the endodontic obturation. I can move it to the other area. If you have a scroll wheel, then you can scroll through the images just like this. So I'm scrolling. So let's see what we can find on the image on the bottom panel with a right click. So some of these options we already know: HU statistics, distance, set filter, reset, save as JPEG. We have a new option which is the display format. Currently it is set at 5:2, which means that we have 5 images and 2 rows. Let's move it to 7:3. So we have 7 and 3 rows. You can see that we are missing the inferior border of the mandible. So I'll just go back and select the default of 5:2. Again, if you want to zoom it, you can do that. Let's do a quick analysis of the premolar and molar region for implant placement. So I'm at the location of the second premolar. So this is the lingual cortical plate, that's the buccal cortical plate, and here is the mantle foramen. You see a B here. This B tells you that this is the buccal surface. So we have some graft materials on the buccal cortical plate. If I go a little distally, somewhere here, inferior alveolar canal is in this location. That's the graft material, very nicely integrated to the buccal cortical plate. This is the lingual cortical plate. If I want to measure this dimension, I can do it by selecting distance. Draw a vertical line from the midline of the alveolar bone to the inferior alveolar canal, and I'm getting about 12 millimeter. At the level of the crest, from the buccal cortical plate to the lingual cortical plate, including the width of the cortex, and I'm getting about 7.33 millimeter. I'll take another measurement at the level of the inferior alveolar canal, and I'm getting about 9 millimeter. I was not very careful here, so try to be as careful as possible for your implant placement. Remember that this image is a vertical image along this line. You may not be placing an implant vertically, but will place an implant parallel to the other premolar. So what can I do? I'll make this image slice a little thinner so that I can see the inferior alveolar canal a little better. So that's the superior border of the canal, and I'll go select from here, and I see about 12 millimeters. So this was also 12.4 and this is also 12.4. So the measurement is pretty accurate. This software also allows you to estimate the location of the inferior alveolar canal, and it's here. We'll review this on a different video. Thank you very much, and I'll see you again on a different video.